Now let's look at a problem where we have an objective function and some constraints that we need to deal with. Find the maximum value of the objective function z equals 3x plus 2y, subject to the following constraints. We're told that x is greater than or equal to 0, y is greater than or equal to 0, x plus y is less than or equal to 6, and x is greater than or equal to 2. In order to find the answer to this question, we're going to have to graph these 4 inequalities, and then we're going to see how to use that in order to get our answer. Now let's start by noting that x greater than or equal to 0, y greater than or equal to 0 means that we're only going to be considering the first quadrant. So we're going to use that right away to tell us that we only have to consider quadrant 1. Next, we're going to be looking at the inequality x plus y is less than or equal to 6. We'll start by graphing the equation x plus y equals 6. We can do this pretty easily by using our intercepts. If x is 0, then y is 6. If y is 0, then x is 6. So let's plot those 2 points. And we'll connect the dots. Notice that this is going to include the border. We want to look at shading in a region where we can use a test point such as 0, 0 to determine which half plane we're going to shade. We're going to substitute in 0 plus 0, that is less than or equal to 6. What that tells us is we're going to be considering the section that I have enclosed in the triangle. Next, let's look at our last inequality. We have x is greater than or equal to 2. We're going to be able to look at the equation x equals 2, which you should recognize as being a vertical line, and that's going to be a border. Next, we want x to be greater than or equal to 2, which means we would have shading to the right to be looking at values that are greater than 2. Now we're going to identify the section where we have an overlap, and that's going to be within the triangle that I have drawn in yellow. To proceed with the problem, what we're now going to do is to identify the vertices of this triangle. So we can look at our first vertex point. That would have coordinates 2, 0. Our second vertex would be here. The coordinates would be 6, 0. Remember, this is the point where we had our x-intercept. And we have a third vertex here. Now we notice that this point is going to be on the line where we have our x value equal to 0, so we know our x-coordinate is going to be 2. It also lies on the line where x plus y equals 6. Since our x and our y coordinates have to equal 6 in order to be on the line, then that means our y coordinate has to be 4. Now we're going to take those 4 vertices. Let's just rewrite it. We have 2, 0, 6, 0, and 2, 4. We're going to take each point and substitute into the objective function. Z will equal, let's go ahead and multiply 3 times our x value of 2 plus 2 times our y value of 0. That's going to give us 6 plus 0, which is equal to 6. Next, we're going to substitute the second point. Z would equal, we do have 3 times 6 plus 2 times 0. That's going to give us 18 plus 0, which is equal to 18. And then lastly, we're going to substitute the 2 and the 4. 2 for x, that would be 3 times 2 plus 2 times our y value of 4. That's going to give us 6 plus 8, which is equal to 14. What we're trying to do now is to find the maximum value, and we can see that that's going to occur with a value of 18. The point that corresponded to that was the point in the middle, 6, 0.